Today, as we discussed, abstract class is a class which contains, right? Abstract class is a class which contains right? So abstract methods, right? So generally speaking here, abstract class is a class which may contain abstract methods or may not contain abstract methods, right? Very important definition here. A abstract class is a class which may contain abstract methods or may not contain abstract methods. But if a class contains at least one abstract method, that class must be declared as what? Abstract. So there is no option left for the programmer. If a class contains at least one abstract method, the class must be abstract. We need to make the class as abstract, right? So how can we make a class as abstract? Just by adding abstract keyword to the class definition. By adding a abstract keyword to the class syntax, then a class becomes a abstract class, right? And if a class contains all implemented methods, still you can make a abstract class. You can still make a class as what? Abstract class. In that case, that is a programmer's choice, right? That is the definition I have given. A abstract class may or may not contain abstract methods, but if it contains the abstract method, the class should be abstract. And if it is not containing, if there are no abstract methods in the class, in that case it is up to the programmer to take that class as abstract or not, right? So as we discussed here, as we discussed here yesterday, we have taken different shapes yesterday to demonstrate this abstract class. So again, the same story which is related to again the inheritance concept. When you have different classes with some common methods, instead of writing these common methods in different classes, right? So we'll be placing all these common methods inside a class called as a superclass, and this class, whatever this class is having, all these things whatever we have in this class can be accessed by using a child class objects. But in all cases it is not possible, as we discussed yesterday's scenario, right? So whenever you have a shape kind of superclass, right? Whenever you have a superclass here, and in that class you cannot, if you have area method which is common to all the shapes, and it is not possible to implement such kind of area method instead of writing, right? So you cannot implement such kind of method inside this. Area is there with every shape, but it is not possible to implement it because every shape will have its own area. And but I want to say that every shape will have an area, but it is not possible to implement it. So it is possible in Java that you can write a method without implementation, and such kind of methods we call as what? Abstract methods, right? Such kind of methods we call as abstract methods. And if a class contains at least one abstract method, the class also need to be declared as what? Abstract. So why I need to add this keyword to a class? Very simple, to easy identification purpose. Yeah, spelling is mistake. Okay, fine. STRACT, both. Fine, I cannot do it now, right? Okay, fine. Now what is the meaning of adding a abstract keyword? What is the meaning of a abstract keyword to a class, right? Right. So what is the meaning of using abstract keyword with a class means? So with a class means, again, as a programmer, to easily identify this class is a some different class. This class is a some different class from what? The normal Java class. So what is the difference you have? STRACT, right? So what is the difference you have between a normal Java class and abstract class? The only one difference you have. Remember this, guys. Only one difference you have between abstract class and normal class. The normal class can be instantiated and abstract class cannot be instantiated. You cannot create an object for abstract classes. Means what? You cannot write new shape. It is restricted. New shape you cannot write. and always you will find this abstract class as superclasses. So the scenario, try to understand the scenario. The scenario, we have come across this new structure, Java structure, because of the common method, and the common method which I cannot implement. The common method which I cannot implement. So in that case, I am leaving the method without unimplemented, and whenever you have a method without implementation, that method we call as what? Abstract method. And the class which contains abstract method, right? And that class also need to be declared as what? Abstract. So but here technically, so how it is different from a normal class? So the class which contains all implementations, that is called as a fully implemented structure, and the class which contains a partial implementations, that is called as what? An abstract class. And you cannot instantiate the abstract class, but what you can do, you can have a reference variable, though it is not possible to instantiate it, but you can have a reference variable. Shape S is equal to what? Now it can have new circle, it can hold the child class object. This is possible, it can hold the circle object. So you can create the reference for abstract classes, but you cannot create the object for the abstract classes, right? And as somebody said, the methods must be inherited. This is majorly, it forces the inheritance. It forces the inheritance. That means what? It forces the child classes to implement the abstract methods. It forces the child class to implement the abstract methods, right? So we'll see whatever we discussed in a programmatical way, so that I'm creating one class here, right? So public class shape, same example, but I am not going to write any area logics for these shapes here. Just try to take this, and I don't know how to implement what is the area, what is the meaning of a area of a shape, but every shape will have an area, but I don't know what is the meaning of a area of a shape. Now I'm going to save this program. One simple method I have added, right? Dot Java, yep, and go to your folder, and then classes, save it. It's already there. Okay, fine. Now let me compile this program. CD and then classes, CD. Okay, fine. Java C shape.java. Your compiler will not compile this, because whenever there are only two things left, there are two things you need to take care. Whenever you write a method, it is possible to write two ways. You can write a method, two different syntaxes. You have a method for a method with body or a method without body. If a method with body, no need to use abstract, and if a method without body, definitely you need to add a abstract keyword to this. It will not allow you to do this. So again, easy to understand. So what is the meaning of abstract? Whenever you see a method with abstract, that means what? This method is not implemented. If you try to use both together, right, and you abstract with implementation, compiler will not allow you to do this, right? So only one thing is possible, either implementation or making it as what? Abstract. Out of these two, one must be there. Yes, method cannot be implemented now. Let me do implementation means what? It is also simply open and close is also said as what? Implementation. Now your compiler will not allow you to do this. Says what? Abstract cannot have what? Abstract method cannot have body. Any one is possible, right? Either body for the method or abstract, not both together. Now it's fine. It's fine, but still there is error in the class. So what is error? Because it is asking you, boss, you have an abstract method inside your class, and your compiler forces you to make the class also what? Abstract. So that means, again, easy to understand for the programmers. Some other programmers who are trying to access this class, they can easily understand, oh, this class contains some kind of abstract methods, so that I cannot create the class. So by seeing this syntax, now this class is fine. What is this class here? Now a class is with abstract method. Now your compiler is happy, it is compiled your program, and it generates you a .class file only, shape.class file. Apart from this, you can have implemented methods also, absolutely fine. So see, always you need to think from the child class point of view whenever you see these abstract classes, because something I'm doing here. Now what is this? So what is the difference between these two methods? What is the difference between these two methods? Both are common methods in different shape classes. But one method I cannot implement, one method I can implement. Both are common methods with each and every shape, but one method I cannot implement and one method I can implement. That is a problem here. So whenever you see, you need to think from the child class point of view. You should not see this as you should not see this as its own like properties, right? So these two methods, whatever I have written, just for your imagination, for example only I'm taking. This is not exact scenario again, right? So both are common between all the shapes, but one method, when I place these two methods inside a superclass, I cannot implement one method, I can implement one method, but these methods are not shape class, these methods are from some other classes, the common methods from some other classes, right? So because I cannot implement this method, I need to make this class as what? Abstract class. And let me write one more class to see more about this class, right? Right. So just I would like to do some experiment on this class. Public class shape main. Again, one more main class I am taking, so that I would like to operate on that class. So what operations are allowed on such kind of partially implemented structures? Public static void main string args, right? Shape s is equals to what? New shape. Now what I am trying to do? I am trying to create an object for abstract class, right? Then no meaning, right? By creating this object, what I can access? You cannot access. There is a one method without implementation. So what is the meaning of creating object for this? No way. There is no meaning, right? Not possible to implement because this is an abstract class. You cannot write this statement, right? Because in simple, it's a common sense point. You can understand here, right? So what should I do with this object? Because there is no complete implementation. So what should I do for that class? I cannot do anything here. Now compile shape main.java. It stops you to do this. What it is saying? But shape is abstract. You cannot instantiate it. Right? It is saying the same thing here. Right. So now how to access these methods, right? Very interesting point here. Whatever the class I have created, this class is not for its own. This class is created because of there are some common methods inside some other classes. So I need to create those classes which are child classes for this. The first class I am creating, public class circle. What is this circle? Extends the properties from what? Shape. Just I am trying to open this and close it. See, this is a very important class I am writing here to understand more about this abstract. So as we have come across yesterday, two problems. If I keep a method, what code I should write? So I cannot write the code, so that is I left it blank. Now what is it guarantees that the child class definitely implements this method? That is also one point. So area is not there in the shape, but the shape, the class which is extending this shape should compulsory have a area. Now if I don't write a area here also, see this, if I don't write a area inside circle also, what is the meaning of area of a circle? Is it called as a shape then? No, right? So let's see what happens if I don't write a area method. Writing area method means what? Writing a area method inside a circle. What is the meaning of this? Superclass method rewriting in the child class. We call it as what? Overriding. Right? You might remember this, right? So writing the superclass method again in the child class, re-implementing the superclass method in the child class is called as what? Overriding. So what happens here? Now let me compile my circle class, Java C, circle.java. what your compiler is saying. Your compiler is stopping you to create this class. What it is saying? Boss, you cannot create the compile circle class now because it does not override. What it is not doing here. It does not override a abstract method called as what? An area. It is not overriding abstract method called as what? Area in a shape. So what is your compiler is forcing? Your compiler is forcing the circle class must implement the area method. There are two options left to the programmer here. What are two options left to the programmer? Right? One option is whenever a child class is created out from a super abstract class, whenever a child class is created from a super abstract class, the child class should override all abstract methods. All abstract methods. See, in this example, I have taken only one. Imagine there are 10 abstract methods inside this shape class. The child class which is extended from that abstract super class should override all methods, each and every method. If this super class contains 10 abstract methods, the child class should override all 10. If it is not overriding at least one also, the compiler will not allow you to do this. That is the first option left for the programmer. So the programmer is forced, who is creating the child class for that abstract class, is forced to compulsory override the method, right? So what is this? I can override the method here. How to override? We know the rules here. You don't use abstract because I am going to provide the implementation for this method. So we don't write abstract here. Now just I would like to write some simple system.out.println. I think you know the rules of overriding. Name and return type, everything should be same, right? Method signature should be same. That is called as what? Overriding. Circles area method. Circles area method. Now let me compile. So what I did here, I have overridden the area method in my child class. So what my compiler is going to do now? Now compiler is happy. Compiler is happy now. It is compiled. So it is forcing the child class to compulsory have one version of what? Area method. Otherwise this class cannot be created. Right? So what about this method then? Get shape method. This implemented method from the super class. Is it also required to override in the circle class? No. It is up to the programmer. He can re-implement it. Absolutely it is there. It is optional case. You can re-implement it or you can leave it. If you require some other functionality, you can override it. If it is not required, just you make use of what? Superclass method. But this abstract method need to be overridden. So if the superclass contains 10 abstract methods, imagine the child class need to override all 10. If it is not missing implementation of at least one abstract method, this class cannot be created. This is the first option left to the programmer. So what it is doing here, it is forcing the child class to compulsory implement it. If it is not implemented, the compiler will not compile your program. There is a second option left for the child class creator. What is the second option? If you don't want to override this method, yes, absolutely it is not compulsory that it should be overridden. If you don't want to override this, there is a second option is left. In that case, this class also need to be declared as what? Abstract. Right? So think here. This is a very key point here. Now what is the meaning of this? If a method which is not overridden from the abstract superclass, if abstract method is not overridden, then the child class also need to be declared as abstract. Now in this case also your compiler allows to create this class. In this case also the compiler will allow you to create this class. There are two ways. You can make a child class out of a abstract superclass. One way is the programmer must override all the abstract methods, or the child class itself also declared as what? Abstract. Now think about this. I am trying to add one implemented method. So it is not compulsory that you should have all abstract methods. Public void some method. As you said, circumference or volume. Let us take volume will be there. I don't think, right? Circumference here. Right? So I am writing something here. System dot out dot print ln of what? Circumference, something here. No, right? Fine. So what I am doing here, try to see this code. This is bit confusing and important also. What I did here, I have created a child class from a abstract superclass, and I have not overridden the area method, so that my class need to be declared as what, abstract. But this class has its own method, specific method, right? This is a specific method to what? This class, circle class, right? Fine. Now what I can do with this class and what I cannot do with this class, this child class? Can you say what I can do with this class and what I cannot do with this class, with this child class? Right, the first thing is, when I remove this abstract keyword out from this circle class, now see, your compiler will not allow you to do this. What it is saying, boss, you are extending a abstract class, you must have one version of area. If you don't have one implementation of area, you cannot create this class. Or your compiler is asking you to make this class as what? Abstract. Fine, I made my class as abstract. What is it? It is option is there. Now what I can do with this class and what I cannot do with this class. What I can do or what I cannot do with this class. Absolutely correct answer, right? Now you cannot also use this class because it is also abstract, and you cannot create the object for what? This class also. Then there is no meaning for shape and there is no meaning for circle, because you cannot create the object for shape, at the same time we cannot create the object for what? Circle, because both are abstract. Then what is the use of the circumference method? How can I access the circumference method here? That internally has this one important point, technical point inside this, right? Because your circle class is also abstract, you cannot make a object for this, you cannot create a object for this class. So if I cannot create an object for the class, then there is no meaning of doing object oriented programming. What is the internal point inside this discussion? What is the point here I am trying to say? Yeah, absolutely. Shape can be extended one more class, no problem. It is inheritance. How many classes you want to have, you can have in the on top of shape also you can write, no problem. Just remember this syntactical. So what I do with these two classes now? Now if I want to access the getShape method, or if I want to access the circumference method, or if I want to access the area method, what should I do in this case? Can anybody say the answer for this? What should I do so that I can call all these methods? Right? So there is no option left in this case. There is only one way if you want to make an object for this class. One way is, right, the first way is remove this abstract and implement abstract method from the superclass. Okay? So if you want to make an object, remove this, implement this method here, and by removing abstract, so that now you can create the object for what? Circle class, and you can access circle methods as well as what? Its own its superclass methods. Circles methods as well as what? Its superclass methods. Now if you don't want to implement it, there is still left one option to the programmer. What he can do? Create a child class for what? Circle class. Create a child class for circle class, right? So what is that here? In this case, what I need to do? If you want to access all these things, there is one more option. Create a child class for what? Circle class, called as what? Let's suppose semicircle, something I'm explanation purpose I'm taking here, right? Now if you want to create this child class for circle class, if you want to create a child class for circle class, what this circle what this child class should do here? What this child class should do here, right? So again I'm trying to experiment on this. So I have not overridden any method, just I'm creating semicircle. What is this I am creating here? I am creating a semicircle without writing any code here. Is it allowed? Is the semicircle class is allowed without writing any code? No. Why? Because superclass methods are child class methods. That is what we have discussed. So abstract area method from the shape class is also a method of what? Circle class. So that means what? If the abstract method is there in the shape, that abstract method is still there in the circle class. That means what? The class which is extending this, okay, it's not shape, it is what? Circle. And there is a abstract method still present here. What is that? Area method. So what this class has to do here now? The semicircle class. What the semicircle class has to do now? Only again two options left for this class. Either re-implement the area method or make this class as also abstract. There are two things. Yes, area method is commented out. What is the meaning of that? Is the reason why area method is commented out, right? Commented out or no, don't implement. Commenting means what? Not there. That is the meaning why. Area method is here, which is abstract, not implemented in its child class. That means what? That abstract method is present here also. So when the abstract method is present here also, that class need to be declared as what? Abstract. At the same time, this is a child class for one more abstract class, and that abstract method is also not implemented here. So for this class, there are only two options left. What are the two options? Either override or make this class as abstract. Now if I make this class as abstract without overriding, now what I can do with this class? Again the same problem. What is that? You cannot create the object for this. So there is no meaning of writing this class also. Right? So what is that? What I'm trying to explain here is, right, very important point here to be noted, technical point here. Now, because I have overridden here, now this class is fine. This class is fine because I have overridden the abstract method which is there in its superclass. Now, what I can do here, by creating the object for this semicircle, I can access this area method and all its superclass methods. Right? What is the technical point inside this? So, an abstract class with abstract method, it forces the child class to compulsory implement what? The abstract methods. If the child class is not implementing the abstract methods, then the child class must be declared as what? Abstract. Otherwise your compiler will not allow you. And if the child class is also declared as abstract, you cannot create the object for it. So that means what? Technically, let's suppose if I have 10 classes in my architecture. In my architecture there are 10 classes, one abstract superclass. Like this I keep on creating the objects. And this is a superclass which has an abstract method, right? This is a superclass. Imagine there is an abstract method in this superclass, and this class obviously becomes what? Abstract class. And right, so what this class which is implementing this class should do here, if it is not overriding the abstract method from this class also need to be declared as what? Abstract, right? So if the class which is extended from abstract class which is not overriding the method from this class also need to be declared as what? Abstract, right? This class also need to be declared as what? Abstract. If this class also not overriding the method, then this class also need to be declared as what? Abstract. So that means what? Means what? If you have an abstract class in the top layers, right? There must be one class which is implementing the abstract methods of that class, right? If the class which is not implementing, if there is no class which is implementing the abstract classes methods of the super abstract class, so that class also need to be declared as what? Abstract. When the child class is also abstract, you cannot create the object. And as we know that if you want to write the programs, if you want to execute the programs in object-oriented programming, you require objects to call the methods and all. Right? So whenever you have abstract superclass, the point here is definitely you need to have a concrete implementation class for that abstract class by overriding all the methods. Right? Right? Then only you can create the object and then only you can access this. So what is the meaning of this? So if you see my objects here, shape with abstract method, circle which is extended from shape, which is not overriding the area method. That is the reason my class should be abstract, so that you cannot create the object for this and you cannot create the object for circle also. And one more class I am extending from this circle. If this class is also not overrides, this class also becomes what? Abstract. So that I cannot how the area method called from shape? What is the meaning of calling the area method from shape? There is no meaning of calling the area method from shape, right? Do you have any meaning of calling the area method from shape without implementation? If a method is not having any implementation, what is the meaning of calling it? There is a meaning for the method. If you have implementation, calling that method is a meaning, right? So here, this class is not implementing, this class also need to be declared as abstract. If this class is also abstract, we cannot create the object for this class. So there is no meaning. So whenever you have a super abstract class, definitely you need to have a implementation for area method somewhere in the hierarchy. Getting me? Whenever you have abstract method in the super class, somewhere you need to have a class with that abstract method implementation. When you do this implementation, then only this becomes a concrete class. Then only you can create the object for this class, right? So the important point here is, what is the important point here? You can create the objects for only fully implemented classes. You can create the objects for only fully implemented classes. You cannot create the objects for partially implemented classes. Right? Getting me? If you have any doubts, now you can ask. Just 2 to 3 important points to be noted here. There are 2 to 3 points to be noted here. The first point here is abstract class. If a abstract method is there in an abstract class, right? So the child class which is extended from this class must override the method. That is the first point. If it is not overriding, the class also need to be declared as abstract. If it is also declared as abstract, you cannot create the object. That's the first point. If you don't create the object, you cannot access the methods, right? So in the hierarchy of the classes, there must be some class which should have implementations. Otherwise, you cannot create. Somebody is asking like this: if I have a volume method, then what is the story? Abstract void volume, right? I am not going to modify anything here, right? See here, abstract area, abstract volume. Is this class is correct? This class, is this class is correct or wrong? Yes. Why? Because it is not overriding the abstract methods. Now let me do one thing. What I am doing here? What I am doing here? I have overridden how many abstract methods? I have overridden how many abstract methods? There are 2 in the superclass, but I have provided implementation for only 1. Now I am removing abstract. Now what is your compiler is going to do? So I am going to compile circle.java here. Carefully observe here what I am doing here. I am going to compile circle.java. No, it is not allowing. Why? Bus, you must override volume method. If you don't override it, you cannot create it. It is saying or not? Yes? Okay? It is not asking area method to implement. Why? Because area is implemented. See this? Okay? Then as a programmer, what should I do for this class? There are 2 options. Either override the volume or make the classes abstract. Yes. Or make the classes what? Abstract. Now if I make my classes abstract, what you cannot do? You cannot create the object. If you are not unable to create the object for this class, no meaning of this class. So what should I do then? If I want to access this area and circumference methods, there is no option. You need to definitely have a child class. That means what? If you have abstract superclass, whatever you have in the abstract superclass, these things should be accessed through child classes only. And child, what? Child concrete class. Now see here, I am going to compile my semicircle. Is this class is correct or wrong? Is this class is correct or wrong? Semicircle, which is extending circle. Yes? Somebody says yes. Wrong. Somebody says wrong. What about others? I am not getting any responses from others. Only 2 are very active. Yes, the same thing I have written. Public class semicircle extends circle. What is the architecture I have here? Classes architecture. In the inheritance, you can have multiple classes. It's not only one super, one sub. right? How many classes you want to write, you can write. What is my architecture of classes? This is the first class, second class, third class. What is my first class here? Shape, circle, semicircle. Shape has two abstract methods. What are those? Area and volume. Now you just imagine, just remember in this way, it is easy. And volume, right? What happened, other guys? There or not? Now what I have overridden in the circle class? I have overridden only one method. What is that? Area. Right? So this class must be abstract because it is directly having abstract methods. Though the circle class is not having any abstract methods. But see, though the circle class is not having any abstract methods, but circle class also need to be abstract. Why? Because superclass methods are child class methods. In the superclass there is abstract method which I don't overridden in the such child class. So there is one abstract method is still present in the circle. So that this class also becomes what? Abstract, right? Getting me? Okay. Now what about this child class again, which I am creating from, extending from what? Circle. My class, now this is the class like this, without any quote, simply plain open and close. Now what about this class then? Is it compiles? Is this class compiles? See the diagram and say yes or no. Ashish says no. Vipin already said the same. But what about remaining two? There guys. Right? Because its superclass is having a abstract method which is volume, right? So this class need to implement it. If this class is not implementing it, so you cannot make this class. Now what is the class I need to compile here? Semicircle, right? See, I will not allow you to do this because your superclass still has one abstract method. So you must override it. If you override it, then only the compiler allows you to what? To make this class, to create this class. Otherwise, this class also need to be declared as abstract. Now what is the meaning if I create this class as abstract? No meaning, right? All are abstracts. How to access the methods? Because you cannot create the object. So that means what? It forces, in the hierarchy of classes, it forces all the methods to, all abstract methods to implement. Void, what is it? Volume. How many methods I need to override here? Only volume is enough because only the volume method is abstract inside a circle class. Now let me compile my program now. Still it is asking me to do this. Why? Because I did not save it, it seems. Still it is doing. Maybe the method syntax is wrong. Void volume. Is the spelling is correct? Absolutely correct. Public void volume. Save this. Save this. Save this. Semicircle extends circle volume. No need because area method is already here. Area method is already here. No need of re-implementing it. It's up to you now. If you want to rewrite the area method here, you can write it. But volume must be overridden. But area is not compulsory. That's your choice. Right? This method, if you want to override in the circle, that's your choice. This method you want to override in the semicircle, it's your choice. But compulsory method which should be overridden is what? Volume method. The problem, what is the problem? I'm just looking at the problem. Everything looks fine, but why my compiler is not compiling? It's fine, it's compiled. Because maybe the saving the classes might be the problem there. Got it, guys? Here. And now, if you want to access the method, implemented methods of this class or this class, there is only one way to access them, through what? This object. So abstract classes forces to implement. So now it is fine. That means what? So whenever you have abstract method in the superclass, definitely you can guarantee that this method will be somewhere present in some of its child classes. If it is not present, you cannot create a class, and objects will be created for only complete class, not for partial classes. Right? You cannot create the object for shape, you cannot create the object for circle because both are abstract. You can create the object for only semicircle. Getting me? Is it okay? Is it okay? Others, if you are clear with this concept, then we can move. Because the classes are not most the important things in the programming. These kind of abstract things are important. Right? If you write a class means what? You will be having only one implementation. If you write like this means what? You will have multiple implementations for the same method. So designing these classes is very important, because if I have this method area, what is the meaning of this? You will have multiple different implementations from this area method. But when you write implement it, only one fixed implementation. This is very important thing. Okay, is it fine? Is it fine now for all? Shall we continue then? Right? Just one fundamental, just you go through the syntaxes. What is the syntax you have? Oh, all are syntactical statements you need to remember. A class, and remember this class I am not creating for shape. This class I am creating for its child classes, right? So a class which has abstract method, it should be abstract compulsory. And you cannot instantiate the object, right? And the second way, if a class which is extending from an abstract class, if it is not overriding the abstract methods, then that class also need to be declared as what? Abstract. Right? So you can create a concrete class only when if you want to create a concrete class by extending abstract class, only one possible way, by overriding all abstract methods. Now see, if you see the semicircle point of view, volume method is overridden, as well as area method is there, as well as what? Get shape is there, as well as what? Circumference is there. Now what is the question here? What if volume method is not in shape class but it is in circle class? Absolutely the same thing. Just you map the things. If it is there inside this, all rules are same. Now apply the rules whatever I have given. Class which is abstract method must be abstract. Now class with abstract method must be abstract. Rule is rule. And it should be overridden. No need to change here. If it is there inside shape, or if it is there inside directly inside a circle, it is fine. Must implement. This abstract volume method is there inside shape class, or it is inside circle class. This class must have it. And objects can be created for only implemented structures, right? So in your hierarchy, if you have 10 classes like this, somewhere the area method and value methods must be implemented. That is must. Getting me? You can have 100 classes in the hierarchy. You can create a concrete class in this hierarchy by implementing these methods only. You cannot create a concrete class without implementing these methods. Getting me? And if you don't have a concrete class, there is no possibility of creating the object. And if you are not able to create the object, you cannot call the methods. Object is mandatory, and objects are created for only classes, not for abstract classes. Getting me? So this is what you can do here. So this is what abstraction guarantees now. So what? Still okay, fine, right? Now I'm going to take you now. This is correct. Is this statement is correct? Is this statement is correct? No. Why? Because you cannot instantiate it. But I can have a reference variable. Is this statement is correct? Circle shape is a super class, reference circle is the object. Yes? No. Why no? Because circle is also abstract. Circle is also abstract, guys, right? Now it is also not allowed. Just remember the syntaxes. It's not semicircle. I need to compile what? Shape main. Right? You cannot instantiate circle because it is abstract class. Now it is correct. Is it correct? It is only one thing is correct. Right? It is correct. Yes. Is that area? Is that volume? What I can call through this reference now? Through this reference, what I can call, guys? Can you say the answer for this? Through this S reference, what I can call? These are my classes. Say me what methods I can call. So first of all, how many methods are there in semicircle class? Its own method, it's like volume method, circumference method, superclass methods also what? Subclass methods, area method, this is also there, and get shape method. All four. One is from shape method, one is shape class, one is from circle, two are from circle class, one is its own. Four methods totally. Now through this statement, can I call all four? Now let me check how much you understand. All four I can call. S dot, what I want to do here? What I want to do here? S dot area is the one method I would like to call. S dot get shape is the second method I would like to call. S dot circumference is the one method I would like to call, one more method, and is that volume. Now can you say what all are correct statements? All methods calls are correct? All we have discussed. Yes, one says yes. Still. No need to implement this. This is already there. Imagine that something is there. I did not return the body statements here. It is implementation. This kind of implementation we generally call as null implementation, nothing. This kind of implementation we call as null implementation. No, nothing. We have written. This is also one null implementation. Just I am not going how they are executed. What is the result of this? What methods I can call? All four statements are correct. These all four statements are correct. Come on. Only get shape method is called. Somebody says only get shape. Fine. One answer. Somebody says only get shape. Next. Quickly. We are running out of time. All will be called. One says all. Fine. Two answers. One says shape only. One says all. Fine. All. Vipin also says all. What about the last? All. And very interesting point here is, right? Everybody is wrong. Everybody is wrong. No single answer is correct. The first key point here is, already I have given all these points. Through the superclass reference, I can call the methods which are present in the superclass. What is the reference I have? Shape reference. Through the shape reference, I can call only the methods which are there in the shape. Your compiler will not know. Your compiler does not know what is circumference and what is volume because they are not there in the shape. Okay? Okay or no? This point did we discuss or not? Yes, I think. I think yes. through the reference of a class, you can call the methods which are there in that class. Now what methods I have here? Area and shape. You can call only those two. Your compiler can refer to only these two methods, but not circumference, but not volume. So these two are wrong, right? So somebody says only get shape. No, you can call two methods. You can call two methods. Why? Because coming to the method calls, compiler will see this one. So these two are not there. Your compiler complains about this. But this method is not implemented. So how it is getting executed, right? That is where the key point. Method will be executed from what? The object. What is the object I have? Semicircle. Then from where the method will be executed? See this concept already have discussed. Area method of shape class will not be executed. Area method on this object will be executed. Object is created for semicircle. Now it starts searching for what? Area method from here. Is it there? No, it goes to its immediate superclass. Is it there? Now method will be executed from what? Circle. Not from shape. Compiler will be mapping to this area method of shape, but runtime executes the area method from what? Circle. Right? Let us see. So I am saying these two methods can be called. These two are absolutely wrong. How many errors? And what it is saying? You cannot do this, boy, because I don't know. Compiler is unable to find these two methods. I already told. Compiler will not able to find this. Yes or no? Yes. You cannot do this. Compiler is not allowing to do this because through this reference you cannot call these two. Absolutely wrong. Now what about these two? Yes. Compiler checks. Compiler will not see whether the method is implemented or not. Compiler will see whether the method is there or not. That's it. It is there. Implemented, unimplemented, doesn't care. Because definitely it will be implemented somewhere. That guarantee you can give, right? Now let me compile my program. Compiler is happy. Runtime is also getting executed. Circle area method. Area method is executed from where? Circle. But no get shape because I don't have any implementation. It is also executed, but it is not giving you any output because of no implementation, no code. Getting me? Okay. Shall I change the statement? Shall I change the statement? Can I write like this? Can I write like this now? Now what I can call, what I cannot call. I think I definitely am expecting the answer, correct answer. What method I can call, what method I cannot call through this S. Circle C, let's suppose. Circle C, what I can call, what I cannot call. Where is the volume? I removed it. Now tell me what I can call, what I cannot call. Cannot call volume. Absolutely correct. Now in this case, I added it now. Now if it is the case, now give me the answers. Call, volume, area and circumference. As well, get shape also can be called. Everything. Don't see these two classes. There is one more super class is there for circle. There is one more super class is there for circle. You need to go through this class also, right? Now in this case, you can call all C dot. Don't see only two classes, guys. There is a big list of circle. There is a big hierarchy of classes will be there. Now you see area, you see circumference, and you can also call volume. All. Shape is also there. Get shape method is also there. Don't look only these two classes because it has its It has one more superclass, so these methods also can be called. All right. C is of type circle. Compiler checks for this area whether it is there or not. Absolutely there. Shape, whether it is there or not in the circle, no, but it is there in its superclass. Fine. Circumference, it is there as well. Volume, it is there. Everything is there. If you are able to call through this difference, absolutely you can call all these methods through semicircle also, no doubt about it. All methods you can call through semicircle. Yes or no? Can I call all with semicircle? This is a bullet point, gunshot. No second thought about it, right? All from superclasses. Okay? Yes or no? Got the concept? That is the meaning of practicing the things, guys. When I explain, the things will be very smooth, very easy. But when come to combination of all these concepts, there is the problem. When you see a single point, it will be easy. When you mix these things with different concepts, there is a problem. Huh? I don't understand. You are really have a doubt or you are testing? Now is it possible somebody is asking like this? Doubt. Who is asked? Vipin. Okay, I don't bother who asked it. Leave it. Is this correct or wrong? Just say this. Semicircle C is equal to new shape. Is it correct or wrong? Vipin says correct. Wrong. Kiran says wrong. No idea. Third option today I got. No idea. That means nobody are practicing. Yes. Nobody are practicing. One I see who is very much interested. Absolutely not correct, guys. I have given this statement also. Subclass reference variable cannot refer to superclass object. Superclass reference only can refer to what subclass object. Again, fundamental rule, syntactical rule. Subclass reference variable cannot refer to superclass object. How can it refer to a superclass object? What is the meaning of? I already told you. Shape is a circle. Shape is not a circle. Shape is a semicircle. Shape is not a semicircle. Shape can be any one. It can be square, rectangle also. Subclass reference cannot refer to a superclass object. Only superclass reference refer to what? Subclass object. And moreover, it cannot be instantiated. It cannot be instantiated, first thing. That is absolutely wrong also. If it is possible to instantiate it also, it is not correct. Go through the rules, guys. It's a very important thing. Right? Think from my side also. When I'm trying to explain something, if I am expecting some answers, you should be. Otherwise, I will also be disappointed. So that I will be in confusion, thinking like whether they are understanding or not. Right? Be careful. It's not possible, and all I have given. I am not asking any new thing to you. Right? Okay then. Is it okay why we should go for abstract classes? Now can I write a main method for this abstract classes? Main, static main method and constructors. Can I write all these things inside abstract class? We have seen a class can contain instance methods, instance variables. It can also have what? Constructors. It can also have a static main method. Can I write all those things inside abstract class? Constructor, can I have a constructor for abstract class? Can I have a main method for abstract class? Right? And that is a key point here. Everything is allowed. Everything is allowed inside a abstract class. All you can write. Absolutely can write. You can have instance variables, you can have constructor, you can have main method. Only the difference. Just remember, only one difference between abstract class and concrete class is concrete class can be created the object, and abstract class cannot have we cannot create the object for abstract class. Remaining everything absolutely possible in abstract class also. Right? Okay. Abstract class can also have constructors, no problem. If you have a doubt, let me write it. Public shape. What I'm trying to do, I'm writing a constructor inside this. Now we know that when you try to create an object for such a subclass, superclass constructors also will be called. That is also we have discussed. So no argument constructor here I have, and this no argument constructor will be called when you create the object for what? Child classes. In this example, this no argument constructor will be called if you create the object for its child class. What is this? Semicircle. See? Subclass object I am creating and superclass constructor getting executed. Yes or no? You can have everything, whatever you write in the normal class, all you can write inside abstract class, but only one difference, you cannot create the object. And if you are unable to create the object, there is no meaning of what? Writing the class. So, and one important point, abstract class things should be accessed always through child classes. If you want to access the implementations from the abstract class, it is only possible through what? The child classes. It is not possible in any other case. So whenever you have abstract superclass, definitely you must have a child class. Getting me? Yes or no? Yes. One, only one. Yes, two. Right? So one more important structure we have inside a Java, that is what? Right? We have seen completely implemented class, that means which contains all implementations. A class with partial implementations we have seen, right? A class with partial implementations we have seen, but still one more type of class also we can create in Java. That class is called as, right? So that is one more class. So fully implemented class, partially implemented class, and there is also possible we can create a fully unimplemented structure. It is also possible to have what? Fully unimplemented structure. Nothing, everything is empty. And that is also possible, and the most important out of all these three different structures. So right, so I can say what? In technical I can say we can create three different type of classes. One is fully implemented class, it is called as a normal class or concrete class. One is partially implemented class, that is called as a abstract class. And one is what? Fully unimplemented structure, or we call it as what? Technically we call it as, right, interface. Very most important. 10 stars for this. Interface. What is interface? We don't use any class keyword for this, but it is also a class only. This is also a class only. To clearly differentiate, there is some special keyword used with this. What is that? The keyword which is used with this is interface. Right? So very special class with all unimplementations. Right? So that is where you come across one. Right? So in simple I can say fully abstract. A fully abstract class is said as an interface. So if you want to define a fully abstract class, we use a keyword called as what? Interface. We don't use a class keyword to this interface. Right? Again we have one more class. Whenever we talk about interface, the bullet point, blind point is it will not have any implementation. It will not have any implementation. So technically what is the meaning of that? All abstract methods. All abstract methods. All abstract methods is said as what? An interface. Okay, let me take one meaningful interface so that you will understand. In the universe, there are different type of objects are there. So we try to understand like this. So I am going to take interface called as flyable, or I am going to take an interface called as movable. What is the meaning of movables? What is the meaning of movables? Again, general example I am taking, exact not scenario. This is, we will not come across this in the programming. What is the meaning of movables? Any object which has moving behavior is called as what? Movables. Can you say the object? A man, a bird, a vehicle. See, do you have any relation between these objects? What I have said, a person, a bird, a vehicle, no relation. But these different type of objects are having some common. What is that? Moving behavior. So how it should be implemented? So we have talked about common objects with unimplemented method. That is one. But here I am talking about what? Different objects but common method. What is the different objects common method? Move will be there inside all different objects. Getting me? Move is a method which is what? Abstract method, and this move is not related to a particular structure of objects, particular group of objects. This is there with a different type of objects. The common method among different objects. How to define this common method? But if it is not possible to write area in the same, if it is not possible to implement area for the same group of objects, set of objects, how can I implement move for a different group of objects? It's not possible, right? Getting me? So by default, such kind of things we call as what? Again, abstract things. Again, the concept is abstract. But when you have all abstracts, then we define them as what? Interfaces, all abstract methods, and they are by default. If you write abstract or if you don't write abstract, they are by default abstract. Right? We'll see what is this. Yeah. Save this with movable and you compile this. You can compile there. That one, no problem. What is it? Java C. Movable. Right? What it generates for you? It is a class only. Movable is a class. Where is it? See, movable dot class file only. Same, a class only. But syntactically, to easy identify, there is a different keyword is given for us. What is that? Now, whenever you come across this, blind point is it has no implementation, completely abstract. Now, I can write like this. So, generally, abstract class demands to abstract class. Whenever you have abstract class, there you must write abstract method by using abstract keyword, compulsory. You must use abstract keyword in abstract class. But coming to interface, if you use or if you don't use, it is fine. Why? By default. It is default case. What is the default case? Everything is abstract. If you write or if you don't write, it is abstract. Now if you want to see this, I am using, already we have seen a profiler. Movable. See, I have written like this, public void move. What it is does? Compiler is adding. If you don't write, compiler adds it, because by default everything is abstract. So that means you cannot even imagine the implementations inside an interface. You cannot even imagine the implementations inside what? Interface. No, absolutely no. Using the abstract or not using the abstract is optional for you, but nobody. If you use or if you don't use, it's okay. It permitted in interfaces. Right? If I explicitly write, if I don't write, by default it is abstract. Right? So it is most important thing. Contains all abstract methods, complete abstract. A class with complete abstraction, abstracted is called as what? Interface. Right? So what a class should do now here? A class which is extending? No. We don't use the extend keyword. Instead of extends, we use what? Implements. What we do here? We don't use the extend keyword. We use implements. Why? Because all methods are what? Extends means what? What is the meaning of, general meaning of extends? Extends means getting something from the superclass. What I am going to get from this class? Because nothing is there inside it. So everything, whatever I have inside this interface, I need to implement. everything. If I have 10 methods, by default all are abstract, and the class which is which wants to have this behavior, it should compulsory implement it. Which should compulsory implement it. Getting me? Now what is that? Now see these classes here. See these classes. I'm going to create some classes. Public class person, or public class car. Car extends? No, it is not extending. Extending means what? Take, which is already there. What is there inside it? Nothing is there. What I'm going to get from that? So what is there I'm going to implement in my own way. What is there inside a movable? In my own way I'm going to implement it. Right? So all rules are applicable here. For abstract class, the rules are same. Oh, there is already a car class. Let me take bike. Rules are same. Class which implements an interface, this class must override all the methods of what? Interface. What is that class here? Bike. The class is overriding an implementing an interface, but it is not overriding the abstract methods. The rules are same, right? Now what this class has to do here? What this class has to do here? This class must override this method. Otherwise, this class again need to be declared as what? Abstract. Same rules. Whatever we have seen with the abstract class, all are same here. Coming to overriding. The class which is implementing an interface, it should override all the methods. Otherwise, the class also should be declared as what? Abstract. Right? Getting me? There's only one point here. Whatever I'm explaining, it is huge discussion you can go with these interfaces. Very important things, interfaces in the Java. Right? So if I have 10 methods, this class should override all 10 methods. Implement all 10 methods. Otherwise, this class need to be declared as abstract. If it is declared as abstract, you cannot instantiate it. That means you need to have one more class. Right? So it must override this method. What is that method? I need to override public. While you override, we don't use any abstract keyword. Remember this. Because I want to have a body for this method. Now this class is fine. Oh, it's a method. Syntax. This class is still. I did not save it. Fine. I did not save it. Fine. Like this, a class can implement what? A class can extend only one class, but a class can implement n number of interfaces. How many? N number of interfaces. Right? A class can extend only one class, but a class can implement a bike, movable. Now I'm going to write one more interface. Only bike can be movable only. No. Let's suppose bike can be runnable. Just example, guys. Don't take as a serious example this one. A serious scenario. Runnable. What a bike can do here? Bike can also run. Now it can be movable as well as what it can be runnable. So what this class has to do? It has to override all the methods from what? The objects which are runs, all those objects are said as what? Runnables. Now what this class has to do here? See, it is saying what? So class bike implements movable runnable, but it is not overriding the method from what? In runnable interface. It should override it. What method it should override it? All methods. Now it should also override the run method. It should also override the run method. Fine. As well as you can have flyable. Bike is a flyable? No. You can create a flyable. The objects any object which flies can be said as what? Flyable. Which has a behavior called as fly can be said as what? Flyables. It's a general discussion, but you have different meaning. But yes, according. So generally interface, the normal definition, if you take general meaning of interface in the English, right? There is a different mechanism, this is different concept actually inside this interface. I made it simple to make you understand. Interface, the general meaning of interface is, it acts like a mediator between what? Two different things. That is the meaning of interface. which acts like a contract between two different parties, right? So if you see, right, agreement kind of thing, you don't know me and I don't know you, but still we are able to work with together. How we are able to work with together each other? You never see me and I never see you, still we are able to interact with each other, because there are some set of standard specifications are defined in between us. There are some standard rules are defined in between us, right? So the rule says what, I am going to take the online class from this time to this time, and you need to pay something, and my content this is, and how many days I am going to explain. So both we are agreed to what, some common set of what rules, and we are continuing this, and I need to do my role and you need to do your role in this agreement, and we have a agreement, and that agreement contains nothing. My agreement contains what? So I am going to take the class from this time to this time. I'm going to take the class from this time to this time, and this is how much I'm going to charge, and your course content will be this and all. There's some specification is there in between us, and I am one side of it and you are one side of it. I am the one who is implementing that specification, and you are the one who is using that specification implementations from me. And such kind of rules generally we define by using interfaces, guidelines, specification rules. Getting me? Everywhere you come across this most important structures, right? So whenever you have such kind of thing, whenever to right, so if you take very basic example, remote control, right? Now I would like to ask one question here quickly, we will wrap this session, right? So if you take a remote controller, a device, a remote controller will be there for different electronic devices. Now let's suppose today I bought a new TV to my house, which I never operated before. Now if I give the remote controller of the TV to you, is it possible for you to operate on that remote controller? My question is simple. Today I bought a new TV. I'd never experienced the operations of the TV before. Now is it possible for me to operate the remote controller of the TV? Today itself, which I brought. You cannot operate all the functionalities, but there is already a definition is written for remote controller. What is that definition which is written for remote controller? Right, which is acting, that the definition is acting like interface between you and that device. Public interface, what is that? There are some rules. If any electronic device which is implemented based on that specification rules, then only that is called as what? A remote controller. Otherwise it is not called as a remote controller, which should have on. And I don't know how this on will be implemented in each and every remote controller. Off, I don't know how this off will be implemented. TV remote controller will have what? On and off. But how it is implemented, I don't know. But still I can use it. Is this on and off behavior will be same with each and every remote controller? Yes? No, right? TV remote operates, the implementation for this on in TV remote is different. And in the projector remote is different, and in all different remotes will be different implementations. Like this, a definition is there. And whenever you see that particular object which has this implementations, that we call as what? Remote controller. It's a very important structure, right? Just remember this, it is a pure full abstract class, and which has various usages. Acts like a interface between two different entities. Acts like a different interface between what? Two different bridge between two different entities, which does not know, but still both can interact. Is the same example. We can take our example. My specification, my course content is the interface between you and me. I am one side of it, you are one side of it. I am implementing it, and you are taking my services. Right? So this is what you have here. Right? So today we'll see one example on this interface. Tomorrow we'll see one more example on this interface, and we'll move on to the next concepts. If you have any doubts, now we can ask.